when the ancient continents of Earth began shifting. This enigma is explained by a new study. One of geology's still puzzling questions is, when did Earth's tectonic plates embark on the process that shaped the continents to become as we know them today, with researchers adhering to several theories regarding when it happened? Now, we know that even the Holy Bible, in Genesis, the first book of the Old Testament, talks about the Earth and how it split apart. The continent split apart, started wandering. So when did that really take place? A team of scientists suggested an answer to the mystery of when the tectonic plates of the Earth first began moving apart to help it evolve into what we see today. Researchers led by a group of scientists from Harvard sought clues in ancient rocks from Australia and South Africa, and according to their study titled Paleomagnetic Evidence for Modern-like Plate Motion Velocities at 3.2 billion years ago, published in Science Advances. These plates were moving at least 3.2 billion years ago, they say. Physics of magnetism. With the quantum diamond microscope paleomagnetic studies of Australia basalt rocks, scientists measured the speed of the Earth's crust, roughly the same for the last giga years or billions of years. This was established after the analysis of one of the oldest fragments of the Earth's crust found in the Pilbara Craton of Western Australia. The data pointed to a latitudinal drift of around 2.5 centimeters every year, occurring some 3.2 billion years ago. So that's pretty fast for that to be happening every single year. The scientists believe this shift is the earliest existing proof that plate motion, similar to that witnessed on Earth today, took place between 2 to 4 billion years ago. And I just want to remind everyone that in one of our recent articles of when Japanese people of Japan of 600 BC claimed that they saw pink skies, and the geologists and the paleoastronomers found that Japan was about 1,400 miles more north. It's like basically where the Kamchatka Peninsula of Russia is today. So in about 1,000 some odd years, it traveled southwest. The whole island of Japan traveled southwest very quickly. So you can imagine the changes that took place billions of years ago. But anyway, scientists believe this shift is the earliest existing proof that plate motion similar to that witnessed on Earth today took place between 2 to 4 billion years ago. They said basically this is one piece of geologic evidence to extend the record of plate tectonics on Earth further back in history. According to Alec Brenner, one of the paper's lead authors and member of Harvard's Paleomagnetic Labs. Hailing the research as supporting the theory that tectonic movement occurred on Earth in its earlier years, he said, based on the evidence we found, it looks like plate tectonics in a much more likely process to have occurred on the early Earth and that argues for an Earth that looks a lot more similar to today's than a lot of people think. The story behind a rock's magnetic history. This research began back in 2017 when Fu and Brenner drilled for rock samples from a portion called the Honeyeater basalt. These were brought back to labs and placed into magnetometers and demagnetizing equipment that shed light on the rock's magnetic history, and it suggested that the rock formed 3.2 billion years ago. The team then used the information coupled with other research to date when the rocks shifted from one point to another, establishing the annual drift of 2.5 centimeters. Fu and Brenner used the novel quantum diamond microscope to confirm their findings. And despite the fact that the time interval of the geologic movement of the tectonic plates established by the study seems to prove their case, the team acknowledged they can not exclude the results to be due to a phenomenon called true polar wonder, polar shift, polar flips. This is something that can also cause the Earth's surface to shift. Plate tectonics timeline. When the first shifts first started in plate tectonics, key to the evolution of life and development of the planet is an issue that has long been debated in geology. And today, our planet's outer shell consists of some 15 tectonic blocks of crust that continents and oceans sit on. Over time, movement of these plates shape the location of the continents, aiding to the formation of new continents. And as the process pushed forth landforms like mountain ranges, it also exposed new rocks to the atmosphere. The latter resulted in chemical reactions that brought forward evolution of life, which is possible only in a stable climate, something these processes achieved on the surface of the Earth over billions of years. And Roger Fu, one of the lead authors of the paper, said, we're trying to understand the geophysical principles that drive the Earth. Fu, an assistant professor of Earth and Planetary Sciences at Harvard University, said, plate tectonics cycles elements that are necessary for life into the Earth and out of it. This new research could be instrumental in understanding other worlds beyond our planet. And Alec Brenner says it really behooves us as we search for planets in other solar systems to understand the whole set of processes that lead to plate tectonics on Earth, that hopefully would give us a sense of how easy it is for plate tectonics to happen in other worlds, especially given all the linkages between plate tectonics, the evolution of life, and the stabilization of climate. The two lead authors of the study, Alec Brenner and Roger Fu, are planning to continue studying data from the Pilbara craton of Australia and other samples from around the world in future experiments. This is on Sputnik News. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.